Hey there, welcome to Math 6, Unit 3, Lesson 8. More about constant speed. And so we're going to investigate constant speed a little bit more today. So first one, activity is called Back on the Treadmill again. And it says, while training for a race, Andre's dad ran 12 miles in 75 minutes on a treadmill. If he runs at that rate, we have two questions here. How long will it take him to run 8 miles? And how far could he run in 30 minutes? So for each one, they're giving us a different one of these. This one gives us miles, and we can see we're working with miles, and this provides minutes, and we're working with minutes. So we can set it up a couple different ways. We've been using tables so far, so let's continue to do a table here real quick. Let's do miles, and let's do minutes, and let's see what we can come up with. First of all, we know that the dad runs 12 miles every 75 minutes, right? That's what we know so far. Now we want to know how long it will take him to run 8 miles, okay? So we want to get to a place where we can say, we want to say what 8 miles is going to be. So I'm going to draw a little line here, because I want to find out what 8 miles is going to be and how long is going to be a time, right? I'm trying to find a time. That's what I don't know, is I don't know how long it's going to take to get there. So the easiest thing to do would be at some point to know what 1, if we made this a 1 times 8 would be. So to go from a 12 to a 1, we know we were going to multiply by 1 over 12. So we'll do that right here, and this becomes 75 over 12. Alright, so, and then we go in times 8. So to find out what the miles per minute will be, if it takes him 8 miles, if he's running 75 over 12 every minute, we would do the 75 over 12, so 75 over 12, and we're going to multiply that by 8. So times 8, and that's like 8 over 1. So we can reduce this here if we wanted to, or we could use a calculator. Let's use a calculator for now. Okay, so let's go ahead and do 75 divided by 12, which is 6.25, and now we're going to multiply that by 8, and we find out that he could actually run 8 miles in 50 minutes. Okay, so we multiply that out, we've come up with 50 minutes there. So what we're doing is we're finding essentially that rate for 1 mile in how many minutes. Okay, and that was at 6.25 is what we found out. So we can find how long it would take by finding how many miles per minute, so, or how many minutes per mile. So this side over here, we're going to do the exact opposite. We're going to set it up with miles again, and we'll do minute. I shouldn't say opposite, I should say probably reciprocal. But here we go. We know he goes 12 miles, and that takes us 75 minutes. In this case, we want to find out how far, so we're looking for the miles part, right? So in terms of what we're looking for how many miles he can run in how many? In 30 minutes. So this becomes my rate that I'm working with. I want this to be 1, and to go from 75 to 1, that is multiplied by 1 over 75. So going here, we do 1 over 75 as well, the same thing. This becomes 12 over 75. Now notice just real quick, what do we see here? We have 75 over 12 and 12 over 75. Those are indeed the reciprocal. To go from 1 to 30 is times 30. So then to go from 12 75ths down over here, we'll multiply by 30. So again, we end up with something like 12 over 75 times 30 is what's going to go in that space right there. So we can use a calculator. We can do 12 divided by 75 equals that. Multiply it by 30, and we come up with 4.8. Alright, using a calculator that works out a little bit better for us, alright? So, using what we know about Andre's dad, 12 miles in 75 minutes, we can use that information, that constant rate that he has, to find out either how many minutes per mile or how many miles per minute. They're going to be a different number, but they actually are reciprocal of each other. From that, then we can find out any set of miles or any set of minutes we want to by multiplying by the right kind of scale factor, right factor there. Okay, 75 over 12 or 12 over 75. Let's look at number 2. Picnics on the rail trail. Now, if you're not sure what a rail trail is, rail trails are going to be places where there used to be railroad tracks long time ago, and the rail tracks are gone, and now you're left with the space the railroad was, and you have a trail that's relatively flat and goes on. You can take nice walks on the trail, and there you go. And we have a few around where we live as well. They're kind of fun. Alright, so Kieran and Claire live 24 miles away from each other along a rail trail. One Saturday, the two friends started walking toward each other along the trail at 8 o'clock a.m. with a plan to have a picnic when they meet. Kieran walks at a speed of 3 miles per hour, while Claire walks at a speed of 3.4 miles per hour. Alright, so what do we have? We have Kieran, who's going at a rate of 3 miles per hour, and we have Claire, who's going at a rate of 3.4 miles per hour. That's what we know so far. We also know that they live 24 miles away. So as kind of a picture here, for example, we could have Kieran's house is here, and Claire's house is here, and we know the whole distance is going to be 24 miles away. That's what we know at this point. So Kieran's going to be walking this speed, this direction, 3.3 miles an hour, and Claire's that way at 3.4 miles an hour. So after 1 hour, how far apart will they be? So we know initially they're 24 miles apart, right? So after 1 hour, Kieran's gone to this point. She's at 3 miles over here. Claire's gone over here at about 3.4 miles. Combined, they've traveled a total of how much? 6.4, right? So 3 plus 3.4 equals 6.4. Now that's not how far apart they are, that's how far they've gone so far. So we'd have to take that number and subtract it from the 24. So if we do a 24 minus 6.4, that tells us how much distance is left here to here, right? And 24 minus 6.4 is going to be 17.6. So after 1 hour, they're 17.6 miles away from each other. Make a table showing how far apart the two friends are after 0 hours, 1 hour, 2 hours, and 3 hours. Alright, so let's make a table. We'll label one side time. So that's what we're looking at here. And then we'll have distance apart. Alright, so after 0 hours, we know that they are 24 miles apart. After 1 hour, we just figured out that they are 17.6 miles apart. And the reason for that is that they're traveling at a 6.4 combined, 6.4 miles per hour combined. So at 2, if we do 2 times 6.4, 2 times 6.4 is going to be 12.8, right? And if we subtract that from the original 24, we find out that they are going to be a whole 11.2 miles away. And after 3 hours, we do 3 times 6.4, which gets you 12, carry the 1, 19.2. And we subtract that from 24. And we end up with 13 minus 9 is 4. So we're at 4.8. So when they start, they're 24 miles apart. After 1 hour, they are 17.6 miles apart. 2 hours, 11.2 miles apart. And 3 miles, they are 4.8 miles apart. It's a long way to go have a picnic with each other, but I guess it's what you do for friends. Okay, so that's what we have so far. Okay, we notice that it's decreasing by 6.4 every hour, right? So clearly by the end of 4 hours, they're going to make it, right? Because 6.4 less is going to be 0 points, going to be somewhere happening between 3 and 4. At some point in there, they're going to actually connect and meet each other between 3 and 4 hours. That's what we know at this point. The next question does ask you, at what time will the two friends meet and have their picnic? And that's a tricky little question, okay? Because what we're saying is we're saying, all right, we know that they're traveling at a rate, essentially combined rate, of 6.4 miles every hour. Okay, that's our time, 6.4 miles every hour. And what we're wanting to find out then is how long will it take them before they reach 24 miles total. That's our idea there. How long will it take them to get to 24? So 6.4, something times 6.4 will get me to 24. Right? That's the idea. So if I multiply this out like this, I would look at something like this. I'd have 6.4 times 24 over 6.4. And the reason I say that is because to go from there, here to here, to get 6.4 to turn to 24, I would have to multiply by 24 over 6.4. Why? because that's going to cancel each other out to get you just 24 right there. Okay, that gets you 24. That's how you got the number there. So in this case, multiplying by the same thing times 24 over 6.4, you end up with 24 divided by 6.4 is what would go essentially right here. Well, what is 24 divided by 6.4? Use a calculator. 24 divided by 6.4 equals 3.75. So how long would it take for them to reach each other? We would say 3.75 hours, which in time-wise is going to be 3 hours and 45 minutes. 3 hours and 45 minutes, because 3/4 of an hour is 45 minutes. Kieran says, if I walk 3 miles per hour toward you, and you walk 3.4 miles an hour towards me, it's the same as if you stay put and I jog 6.4 miles per hour. What do you think Kieran means by that? Well, notice here, what is a 6.4? That's going to be the sum of her speed of 3 and the other speed of 3.4. That's 6.4. So the total distance traveled stays the same. The difference is what? Initially, Kieran and Claire are like this, and they're walking towards each other, and they eventually meet in the middle. If Kieran's moving at 6.4 miles per hour, and Claire just stays here and doesn't move at all, then all the motion is going to come this way. So yes, it would still take the same amount of time, because 6.4 times that 3.75 is still going to get you 24. It's going to get you 24 miles. You'll still get there at the same time. The difference is you're going to arrive where? At Claire's house. You're not going to arrive in the middle. And that's the big difference there. So we agree it's the same amount of time, but the nice thing is one person stays home and one person does all the walking. All right, so off they go. Several months later, it says they both set out at 8 o'clock again, this time with Kieran jogging and Claire still walking at 3.4 miles per hour. This time they meet at 10:30 a.m. How fast was Kieran jogging? Okay, so in this case we can see that the time, it's only going to take 2.5 hours to meet with each other, right? That's what we know so far. So we know that for Claire does that rate for 2.5 hours. So 3.4 times 2.5 hours, that's going to give you, let's multiply here, we have 20, we have 15, 16, 17, and we have 8, and we have a 6, so we end up with 8.5. So how far does Claire actually go? Claire travels 8.5 miles. We know there's a total of 24 miles to cover. So by subtracting the how far Claire went from the total, we can see how far Kieran actually went. So we borrow here, and we have 10 minus 5 is 5. We borrow here, 13 minus 8 is 5. So we know that, bring the 1 down, 15. We know that she's going 15.5 miles, and she does that in 2.5 hours. Right? So how fast is she jogging? Well, 15.5 miles in 2.5 hours. And so we want to find out what that is in miles per hour. We would do 15.5, 2.5. You want to make that into a 1 for 1 hour. That's our speed. So we're going to divide by 0.25, or 2.5. So if we do 15.5 divided by 2.5. Why? Because we're multiplying by 1 over 2.5 to get that to 1. So it's the same as dividing by. We end up with 6.2. So what rate is she going? She's going 6.2 miles per hour. And that's her rate right there. Okay, and that's the idea. All right, we're going to skip this one right here, and we're going to move on to activity 3, swimming and biking. Last activity for the day. It says that Jada bikes 2 miles in 12 minutes, and the cousin swims for 1 mile in 24 minutes. Who's moving faster, and by how much? So let's put these into the same type of of units, okay? So we have Jada, and we have the cousin. So we have miles, and we have minutes, and we know we're going 2 miles in 12 minutes. Over here for the cousin, we have miles, and we have minutes, and we have 1 mile in 24 minutes. All right, that's what we know so far. So who's moving faster? Well, this person already is doing 1 mile in 24 minutes. This person does 2 miles in 12 minutes. So it's definitely going faster, right? Because they're doing going twice as far in half the time. But if I put this in terms of 1 mile, so multiplying by a half, we can see that we're going 1 mile every 6 minutes, and this person's going 1 mile every 24 minutes. Okay, so our difference in our rate is going to be here. Our speed is 1 mile in 6 minutes or 1 mile in 24 minutes. So for sure we know that Jada is going faster, 1 mile every 6 minutes. That's the first part there. And how much faster is she going? Well, that's going to be a different question, right? We want to figure out how much faster is she going in terms of kind of their miles per minute. Okay, so here we have 1 mile per minute, and this is 1 mile per 24 minutes. So what probably is good is to put this in terms of, when we're comparing speeds, we usually do that in kind of miles per hour. That's typically what we look at for when we're looking at speeds there. So we want to put the 1 back on this side over here. So to go from 6 to 1, that's going to be multiplying by 1/6. So we have 1/6 mile per minute. With me so far? And here we make this into a 1. This becomes 1/24 miles per minute. Okay, so speed is usually miles per hour, and we're in minutes. So there are 60 minutes in 1 hour. So we're going to take this number and we're going to complete our table here. We're going to make this into 60. So we're going to multiply this by 60. So we have 60 over 24. And over here we're going to have 60, sorry, out of space, 60 over 6. Because we're multiplied by 60. So for Jada is 60 over 6, which is 10 miles per hour. And the cousin is 60 over 24, which is going to be 2.5 miles per hour. So how much faster is Jada than the cousin? We could subtract and find the difference, and we have 7.5 miles per hour faster. So a couple of extra steps there to convert this into miles per hour. And the reason for that is that when you're talking about speed and how fast someone's going, we always put that in terms of the miles per hour. You could do miles per minute too, but that's what we're doing, just by hour. That's the typical way we talk about speed, and that's it. Okay, one day, Jada and her cousin line up on the end of a swimming pier, and on the edge of a lake. At the same time, they start swimming and biking in opposite directions. So one's going this way, and one's going that way. Okay, so off they go. How far away would they be after 15 minutes? Let's come back up here. And we know that our rate for 1 minute for Jada, for 1 minute, she's going 1/6 of a mile per minute. We know that from this point right there. So after 15 minutes, how far has she gone? That's 15 divided by 6, which is 15 over 6. 3 goes in here 5 times, 3 goes in here 2 times. So we have 2.5 miles there. And for the cousin's going 1 over 24 for 15 minutes. So you end up with 15 over 24. 3 goes into here 5 times, 3 goes in here 8 times. All right, and so in terms of how far apart they are, now we have to combine 5 halves and 5 over 8. Okay, so we can do that by either turning into a decimal or adding fractions together. Let's add fractions together real quick on the side. So we have 5 over 2 plus, let's go 5 over 8. The common denominator here is going to be the 8, right? Because 2 times 4 is 8, so 5 times 4 is 20. Now we'll combine 20 plus 5 is 25 over 8. 8 goes into 25 3 times, for 24 with 1 remainder. So we have 3 and 1/8. So how far apart will they be after 15 minutes? They're going to be 3 and 1/8 of a mile apart. So sorry about that zigzag work in there, but that's all the space I had. How long will it take them to be 5 miles apart? So how long will it take to get 5 miles apart? Okay, so we know right now that they are, right now, after 15 minutes, they are 25/8 of a mile apart there, right? So what we can do is we can say that in miles and minutes, what we know is they are 25/8 miles apart after 15 minutes. Okay, so then to say, well, what's it take to get to 5 miles? It's kind of our idea. How do we get to 5 miles apart? We want to turn that into a 5. So what I thought about is I thought 25/8. If I want to turn the top number into a 5, I have to multiply it, right? I want to get this to be a 5. What do I multiply by to get this equal to 5? I got to put an 8 on top so it goes away, right? So the 8 cancels out. And if I put a 5 on the bottom, this reduces to being 5/1. So I'm going to say it's 8/5 of an hour, which is basically going to be 1 3/5 of an hour. How much is that? I'm not sure. But that's what you got there. Those are some really crazy numbers. I don't think you'll see a lot of crazy numbers like that. I know in the homework there's not so much, so don't worry too much about that last problem. A lot of funny numbers going on there, a lot of things that this is one of the trickier lessons in this unit. Okay, so if you got stuck on this one, that's okay. It'll start to make more sense with time, so don't worry about it too much. So in summary, when two objects are moving at a constant speed and their distance to time ratios are equivalent, we say they're moving at the same speed. If their time distance ratios are not equivalent, they are not moving at the same speed. We describe speed in units of distance per time, like miles per hour, and we describe pace as things like hours per mile or seconds per meter. So when it's a per hour, that's a speed. When it's a per distance, right, then it's a pace. So you have some examples here of differences between speed and pace, but really they're the same idea, just different sides of the coin, right? Alright, so we're going to pause there and give you a moment to work on your homework, and then we'll come back and check that together in just a minute. Alright, here's our homework for lesson 8. A kangaroo hops 2 kilometers in 3 minutes. At this rate, how long does it take the kangaroo to travel 5 kilometers? So let's set up a little table here. We have kilometers, and we have minutes, and we know that we're doing 2 kilometers in 3 minutes, and we want to find out about the 5. So let's go ahead, 5 kilometers. That's our goal. So whenever they give us this one, we're going to work this down to be our 1 value. Okay, so to go from 2 to 1, that's multiplying by a half. So we multiply by a half over here. We have 3 over 2. And then to go from 1 to the next thing, which is 5 kilometers, I multiply by 5. So multiplying by 5 here, I have 5 times 3 over 2. 5 times 3 is 15, and I have a 2 on the denominator. So 15 over 2 equals 7.5 minutes is how long that's going to take. How far does a kangaroo travel in 2 minutes? Okay, so same idea, kilometers, minutes, and we already know, we have 2 to 3. Okay, we could keep it like that. I'll go and keep it like that for now, just to show you something else again real quick. And because we're going to do 2 minutes, we're going to make this our 1 value. And when that's our 1 value, what do we say about over here? It becomes the what? The reciprocal. So 2 over 3. Right, this becomes times 1/3, this is times 1/3, so it's 2 over 3, reciprocal there. So the minutes we're looking at here are 2, so we're moving from 1 to 2, so that's times 2, times 2. 2/3 times 2 is 4/3, and 4/3 is the same as 1 1/3, or just leave it as 4/3 there, it's the same thing. Number 2. May runs around a 400-meter track at a constant speed of 250 meters per minute. Way to go. How many minutes does it take May to complete 4 laps of the track? Now 4 laps is 4 of the 400 meters, so 400 times 4 is 1600 meters is how far she's going to go. Okay, what do we know? We know that in terms of what she's doing, meters and minutes, she's going at a rate of 250 meters every 1 minute. We know that she needs to end up going 1600 meters in total. So what we're trying to find out is, what am I going to multiply by to go from 250 to 1600, and then whatever that is, that'll tell me how many minutes it's going to take to get there. Okay, so to go from 250 to 1600, well, that's a little tricky there, right? That's going to be multiplied 250 times, what do we want to say, 1600 over 250. Why? Because that cancels out and leaves you with just a 1600. So whatever we multiply by on this side, we multiply by on this side. So what do we multiply by over here? 1 is multiplied by 1600 over 250. Do you know what that is? I certainly do not. So I turn on my calculator and I do 1600 divided by 250, which gives me 6.4. So it'll take 6.4 minutes to go 1600 meters. Okay, and then we found that out by doing what? By finding out what this multiplier is going to be and doing it over here as well, and then just using a calculator. Number 3, at 10 a.m., Han and Tyler both started running toward each other from opposite ends of a 10-mile path along the river. Han runs at a pace of 12 minutes per mile. Tyler is 15 minutes per mile. So, how far does Han go after half of an hour? Okay, Han's pace is 12 minutes per mile, right? So we know that he does 12 minutes. Let's make this like this. Make a table here real quick. So here's Han. We have minutes and we have miles. And what do we know? We know he does 12 minutes in 1 mile. So for half of an hour, that's going to be half an hour. Oops, look at this. Let's go see how many miles it is in 1 minute. 1 minute is going to be 1/12 of a mile, multiplied by 1 over 12, multiplied by 1 over 12. So then to go half of an hour is 30, so times 30. We end up multiplying this by 30. You have 30 over 12. 30 over 12 is the same as 5 over 2, which is the same as 2.5. Right? So 2.5 miles after half an hour. After an hour, we would double it. We do 2.5 times 2 and say 5 miles. Okay? So 5 miles for that one and 2.5 for that one. Do Han and Tyler meet on the path within 1 hour? Explain or show your reasoning. Okay, well, we know that Han goes 5 miles in that 1 hour period. We got that done so far. We know they have to go a total of 10 miles in order to connect to each other. So the question is, how far does Tyler go in 1 hour? So we have to find out Tyler. Tyler is running in terms of minutes per mile or miles per minute. Doesn't matter which one you put first. Really doesn't matter. He's doing 15 minutes per 1 mile. So we want to find out how much that is a minute per mile. It's 1 over 15. Right? And then if we do we could say, well, we want to find out for a whole hour. Keep it the same. This is miles per hour. So after 60 minutes, this becomes 60 over 15. And 60 over 15 is the same as what? 4. So Han's going to go 5 miles in an hour. Tyler's going to go 4 miles in an hour, which is a total of 9 miles, but they have to go 10. So because they're 10, they are 1 hour apart after 1 hour. All right. Next question. 2 skateboarders start a race at the same time. Skateboarder A travels at a steady rate of 15 feet per second. All right, so what do we have? A is doing 15 feet per 1 second. B travels at a steady rate of 22 feet per second. After 4 minutes, how much farther would skateboard B have traveled? Okay, so this is going to be our time, right? This is our feet and our time. If this is a second, we're going to multiply by 60 to get to a minute, right? So if I multiply by 60, I end up with 60, which is a minute. 60 times 15 is 900. Multiply this by 60. 22 times 60 is 1320. Okay, so now this is 1 minute, correct? You okay with that? 1 minute. 1 minute, 1 minute. Same idea. So now we're going to go after 4 minutes, which means what? I multiply this by 4. Multiply this by 4. So we have 3,600 here. And we have 5,280 here, which is our 4 minutes, 4 minutes. So I did kind of skip a little step there and did a little mental math. I went from 60 to 1 just to put it into minutes. So 5280. So how much farther would skateboarder B have gone? He's gone 5280 compared to the 3,600 of A. And so we subtract, and we end up with 1,680 is our difference there. Number 5. There are 4 tablespoons in a quarter cup. There are 2 cups in 1 pint. How many tablespoons are in 1 pint? All right, so here's what we have here. We have, idea being, we have, it says draw a double number line if you want to. So if we did tablespoons, tablespoons is capital T. Tablespoons is here. We know that when we have 4 tablespoons, we have, in terms of cups, we have a quarter cup, 1/4 of a cup. But when it comes to pints, pints are going to be when you get to 2 cups are in a pint. So I have to go to over here. I won't even worry about a mark there. This is my cup. Let's go quarter, half, 3/4, and 1 cup. All right, extend this out. Quarter, half, 3/4, 2. So when I get to 2 cups, I'm finally going to be at 1 pint. 1 pint here. Okay? So, what do we know then? If this is 4, I'm going to continue this out. 1, 2, 3, 4, 5, 6, 7. Ish, right? 7-ish. Actually, it's more like 8. That's okay, because we're starting at zeros. 0 and 0. And this is technically 0 right here. So get rid of that one there. Alright, so the quarter cup is here. So quarter cup is with 4 tablespoons, and then 2 cups is 1 pint. Okay, so for every one of these, I'm counting by 4. I'm going to go out the same amount. So this is a quarter. 1, 2, 3, 4, 5, 6, 7 more of those. So we're at 4. We're at 8, 12, 16, 20, 24, 28, and we get to 32. So basically, you end up with 4 times 8, which is 32. It's going to take 32 tablespoons in order to get there. All right, that's what you got. And number 6. 2 larger cubes are made out of unit cubes. Cube A is a 2 by 2 by 2, and cube B is a 4 by 4 by 4. The side length of cube B is twice that of cube A. Yes, 2 times 2 is 4. Is the surface area of cube B also twice that of A? We're going to say nope, right? So surface area for A's surface area is going to be the area of the face, which is 4 square units, times the number of faces there are, which is 6. So it's 24, what do they say, inches? No, doesn't say. Let's just say units squared. Now for B, the area of the face is 1, 2, 3, 4 by 4, which is 16 times 6 faces. And 16 times 6 faces is 96 units squared. So B is much, much larger than that one. It's more than double, way more. And for letter B, we're talking about volume here, is volume twice. Well, the volume for A is going to be 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And the volume of B is a 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. Again, that is way more than double, because double would be 16, so it's just not going to be quite right there. Alright, a little bit of a longer, trickier lesson there. The next ones are a little bit nicer. That's it for today. We'll see you next time.